easiest one, so I'm going to put them right here. We'll fill in the covers first. The first cover is going to be called the product property. The product property, product means multiply in math. So usually you're going to have like a to the nth power times a to the nth power. And the properties are the same from last year. Does anybody remember if you're multiplying what you actually do with your exponents? Because you're not multiplying them.
You add them.
You add them. In general, multiplication gets bigger. 2 times 3 is 6. It's getting larger. But instead of multiplying the exponents, you also have to make them get bigger, but not using the same property. So we're going to add them. So I would keep the base, which is a, and I'm going to do m plus n. The bottom one we're going to say is called power of a power. And this is whenever you already have something raised to a power and it's going to be raised again to another power. Let me check. Oh. So this is going to be a to the mth in parentheses, raised again to the nth power. Does anybody remember what we do with these ones?
Don't you multiply the exponents?
You multiply the exponents. So it would be a to the m times n. So we're going to start with the top one, but those are the 2 cover pieces. We're going to open up this one and we're going to do 4 examples. So try to like manage your space accordingly. We're going to use that entire space to do our 4 examples. So I'm going to do probably the first 2, try to do it on the top flap, and then the bottom 2 in the middle like section. Okay. So underneath this flap, I'm going to first rewrite the rule at the top just so that way it's right in front of your face. So a to the m times a to the n. And if I'm multiplying, I am actually adding them. So a to the m plus n. And I'll try to zoom in. Yep, product property. So for question 1, we're going to kind of keep it easy. We have 6 n to the 3rd multiplied by 2 n to the 7th. These are both being multiplied together. So I'm going to not multiply my exponents. I'm going to add my exponents. But I also have coefficients. What am I going to do with those coefficients? Multiply them. You're going to multiply the coefficients. You add the exponents. You're never going to use the same property with the small numbers and the big numbers. The big numbers, you're going to do normal multiplication. The small numbers are the weirdo. You have to think, I'm not multiplying. I'm getting bigger, so I'm going to add them.
So it's 12 and 10. 12 n to the 10th power.
Yes. So I'm going to do 6 times 2, keep the n, add the exponents, 3 plus 7. When you're doing your homework today, you do not need to show work. I know you're going to be able to do this super fast. So the final answer is 12 n to the 10th. How do we feel? That's it. So you multiply the coefficients, you add the exponents. Has everybody got the hole puncher?
No.
The front table. There's 2. Question 2, my hole punch is in the way, but it's okay. Question 2, I'm going to say I have 3p t cubed multiplied by p cubed t to the 4th. So what 2 numbers are actually getting multiplied together? What are my big numbers? 3 and 1. Technically, there's not a 1, but there is a 1 because that's like just like if there's an x by itself, it's 1x. So I'm going to do 3 times 1. Now there's multiple variables. I'm not going to just add them all up together. They're separate variables. Only friends and friends go together. They don't like their outsiders. So the p's are friends. They are like each other.
So is it 3p is 3t? Wait, so
P1
is it
plus
3p 3t7?
No. Does anybody remember if it does not have an exponent, what's actually there? It is a 1. It represents technically how many total of that variable you have. If you have 3 p's over here and you got 1 p over here, that's a total of 4 p's. So if it doesn't have an exponent, then it counts as 1.
Is it 3p to the 4th power and then t to the 7th power?
Yes. What? Can you put it by the bin? So similar variables go with similar variables. If it doesn't have a friend, you cannot add it together. It has to be the same.
Can we just say
We
T
like
to
our
the
own
7?
kind.
Can we say T to the 7?
Yes. So this would be 3p to the 4th, t to the 7th.
Okay, I understand because it's T.
T's go with T's. P's go with P's. Okay? So P's go with P's, T's go with T's. X's go with X's, Y's go with Y's. Yes. I want you to try one. You ready? No? It's okay, I believe in you. You'll survive.
No,
Maybe.
probably not.
So take a minute, try this one. I'm put 3 and 4 up here. If you could do this without work, I'm cool with that for today. Actually, we'll do 3 first, because 4 might look a little scary. Try 3.
Okay.
Are you done? Let people
I'm
think.
done too.
Poor Brooklyn. Let Brooklyn think. She's a little slow. We still love her though.
Look at Brooklyn. What?
Shut up.
Oh, I said, where are you? Calm down.
Recorded.
I think the default for Brooklyn is being aggressive.
Yeah.
Like you could just be like hi and she'd be like, oh, do you want me?"
Oh my God.
She's
I'm not even mean.
You're not, but you can be feisty sometimes. Not to me, but to other people. I've heard it, and I'm like, whoa, Brooklyn. Simmer down. Okay, if I multiply the coefficients, what's my new coefficient? 21. I have y, and what two numbers am I adding? 4 and 5, the little numbers up top, and that makes what?
21 to the 9th power.
21 y to the 9th power. Did we get that?
Yeah.
Okay, you ready to try the other one?
Yeah.
Miss Halleck, if I get this right, can I shout myself out?
Yeah, just show me out.
You can tell me the answer if you want to try and tell me the answer, but let people think. Don't shout it out, but I'll let you say it out loud.
Can we
I'm
get a
not
shout
enough
out?
space on my thing.
Exactly. Like, dang. Why are we having so many
Right.
cells?
Very small, I'm sorry. This is the last one. You don't need to show work. You could skip the work, technically.
Okay, guys, we got
Think. Friends only go with friends. X's go with X's. T's go with T's. R's go with R's. We don't like outsiders here.
Miss Halleck, when it's time to answer, let me answer, please.
Yeah, I will. You can try.
I feel like I got it, but I don't want to be too confident.
That's noise. Good job, Josh. That's not right. Sucks to suck.
Right, but no.
So they got it
We
wrong.
don't like this.
Huh? Yeah, bring. Yeah, yours is good.
And you hand it over.
Yours is good. That's not right. Go away.
Dang it. It's okay, at least we're both happy.
Oh God, Josh, look what you started. Yours is good.
Okay.
Yours is good.
I need help.
You're just doing this now.
I think I did mine right.
Yours is not right. The R's go together. So you have one R here. So that's. You wrote the problem wrong. You wrote the problem wrong. No, yours is wrong.
How?
Let me see.
How was mine wrong?
Okay, back up. You guys all need to go to your seat. I know you're like excited to show me an answer, but like, no, go away, go away, go away. Okay. -4. Shh. Go sit down. -4 times -6 gets positive 24.
Okay.
Brooklyn, you put 2 X's here. It's an R.
No.
Okay. The coefficients make positive 24. Then you have an R. It doesn't have an exponent. It's technically an exponent of 1. How many total R's do I have? 6. So it's R to the 6. I have X. How many total X's do I have?
5.
No. I have 2 and I have 2.
Oh, I wrote the problem wrong.
You have to write the problem correct to get the right answer. Your EOC is on a computer. You need to look at a screen, copy it on your paper, do the math, and then put it back on the computer properly.
I think that applies to every math problem.
And then T to the 3rd. T has no friends. It's chilling like a villain by itself, lonesome, so it does not change. Okay. We have one other flap. Focus. We have one other flap of our foldable that we need to do today. Once we finish this flap, we're done for the day, okay?
Do we have any homework?
Shh.
Yeah, of course we have homework.
Yes, but my plan is not to give you homework tomorrow. So let's get through what we need to get through. That way we don't have homework tomorrow. It's Halloween weekend. I don't want to give you homework. If I have to, I really will. Shh. Before I change my mind.
That means you know IXL?
You have IXL since Monday. You should have been doing that this whole time.
No, I always do mine on the weekend.
Well, then you better do it tonight. Okay, power of a power. This is where you multiply. So I want you to open up this flap. If you would like to draw a line separating them so you don't get confused with question.
That's what I do. I put mine down.
Okay, great. Shh.
We didn't ask.
Nope, we did not.
You know what, Brooklyn?
Once again, I'm going to write the rule first, so that way it's right in front of your face. I have a to the nth power raised to the nth power. This is not adding them, this is multiplying them. So I'm going to take a raised to the m, multiply it by n. Shh. We're almost done. So question 1. I'm going to have 2 x y squared raised to the 3rd. What? So the way I want you to think about this is there is parentheses. You are multiplying. So I want you to think about it as the distributive property. It is not the distributive property, but I want you to think about it like that, similar. So you have to distribute that power that's on the outside to everything that's in the parentheses. So what is the first thing that's going to get that power of 3?
2.
The 2. Then it's going to go to the x, which has a 1. And then it's going to go to the y squared, okay? So I have 2 to the 3rd. Technically, x doesn't have an exponent, but what is this exponent right now?
1.
So I have x 1 times 3, and that's why normally you don't show your work, because if it doesn't have an exponent of 1, it's just basically getting that 3. And then I have y. What 2 numbers am I multiplying together? 2 times 3. So,
How is it not like the distributive property?
Why are we not?
because the distributive property is not technically exponents, but I say it's similar to the distributive property. Think about it as a distributive property. Does anybody know what 2 to the 3rd power is? 8.
We have to solve
X to the power of
it. 3rd.
y to the power of
6.
6.
So it's 8x cubed and y to the power of 6.
Okay, question 2.
Cubed is 3. Cubed is 3.
Yes. Yeah.
Oh, you think it was
So, no.
No, I just think
Shh. We're almost done. So take a minute.
Are we doing all these today?
No, we're doing only 2 flaps.
I was gonna say, I'm figuring out enough time.
Each flap gets 4 problems.
Is that 4?
That is a Z.
yes.
I think people in your class today forgot we were recording.
What?
I think people in your
Ooh,
class forgot we
Miss
were
Halle,
recording.
can I say the answer?
Yeah, tell me.
It's x to the power of 10, y to the power of 5, and z to the power of 15.
Perfect.
Don't need.
If it has an exponent, it's getting multiplied with that. If it does not have an exponent, it's technically 1, so it's just going to make that exponent anyways because it'll be 1 times 5. So you could really just stick that 5 with it. Whenever you do your homework, I am okay with tonight you not showing work. I totally understand, like, you should be able to do most of this in your head. If you want to show work, by all means, show work. Okay, let's do the last 2. Question? Yeah, I think it's like 10. Question 3 is going to be 1/2
Why do you feel the need to add fractions?
x squared to the power of 3. The rule still applies. It's going to go to the 1/2, but instead of going to one number, a fraction has 2 numbers. That power is going to go to the numerator and to the denominator.
Really?
Yes.
So what? 3
No.
No.
Wait, no.
Wait.
Okay, let's do this one together. So I'm going to bring,
It is 1/8. I got it. I got it.
How?
Is it 1/8 x to the 6th power?
Yes.
Can you help what you got? 1/8 x. Yeah. Go. Okay, sorry.
Oh, it's X.
Yes, exponents.
I thought everyone forgot.
the louder you guys are in class, this possibly cannot be posted because it's not, you're not going to hear me anyways. Shut up.
Don't even post. I'm hoping not.
Okay, I'm about to go over it. I have to bring the 3 into the fraction. It has to go to the numerator and to the denominator. So this really is making 1 to the power of 3, 2 to the power of 3. X already has a power, so I'm doing 2 times 3 because X has a power of 2. It's getting dragged with the 3. 1 to the 3rd power is 1 multiplied by 1 multiplied by 1, which is 1. 2 to the 3rd power is not 2 times 3, it's 2 multiplied by 2 multiplied by 2, which makes 8. X to the power of 6. Now there is technically another way you could write this same exact answer. Does anybody know another way I could say 1/8 not as a fraction or not as a decimal?
Is it just 16?
Not as a decimal.
Not as a decimal. Keeping a fraction, there's somewhere else that X to the 6th power could possibly go.
On the fraction?
On the fraction with which number?
The 1.
The 1. So really you could say X to the 6th divided by 8. Either one of these is I'm fine with, doesn't matter. When we get closer towards the end of the unit, a couple days in, I'm going to say positives go in the numerator, negatives go in the denominator. If you remember that from last year, it's where we're headed. What's up? Yes. So once we get to the end of this foldable, we're going to talk about negative exponents, and those ones, if you remember from last year, they go in the denominator and become positive. Last question. I want you to take a minute and think about this one.
I'm going to get a rest of this.
Okay.
I'm going to call it.
I believe in you.
I
Oh,
believe
wait,
in
let's
myself.
get another fraction.
I don't like it. I can't wait for you to go home. I want to eat it.
Yes.
I want to eat it.
Yes.
Bro!
And what?
That's a key, right?
It's 2 to the power of 3, raised again to the power of 2, raised again to the power of 4.
Wait, I think I got this.
This is mine.
Yeah, what is the power thing for?
We're gonna have some big number for that on it.
Yeah. Yeah.
Do we,
Multiply
You sit on a calculator.
No, you just multiply the powers.
Oh shoot. Yeah, go me.
Oh, wait. Exponents.
I don't know what that is.
Okay. what you do, and I heard people saying it, 2 to the 24th power. What is 2 to the 24th power? All you do is, it's like 16 million and some craziness. So what you're going to do is you keep the base, which is the 2, and you multiply all the numbers together. You could just, it doesn't matter what order you do it in, because if I have 8 times 3 or if I have 6 times 4, I'm going to get the same amount. No matter which way you multiply numbers together, it's going to make the same number.
Yeah, because you can do 2 to the power.
So 2 to the 24th power, you can just write that as your answer. If you really want to put 16 million and whatever, then you can do that. But if it's something simple, like 2 to the 3rd power, I would expect you in class to simplify that. If it's something crazy, like 15 to the power of 10, do not do that, okay? Most of your calculators, once we get into the higher exponents, can't even like write it out. So if you want to write the answer, write the answer. If you don't, if you want to like keep it like, you know, like that, I'm cool with that, okay? But if it's something small, please solve it. Like 6 to the 5th power, okay? You can plug that in your calculator. How are we feeling? Are we stressed? If you want to leave it like this, leave it like this. If you want to write the whole number, then you should write the whole number, okay? So your homework, what's up?
Where do we write 59?
59 on the back of this. You are going to put your name and number 59.
Miss, how the answer would have been 16,777,000. Wait, we write this on.
Oh my God, did you do that in your head? You're such a genius.
Yeah, I totally did that.
Mental math. Matilda. You are writing your name on the back. You are writing number 59.
In the back, I wrote it in the front like you did.
This is on the back.
That's the back?
This is the back.
Oh,
I knew
wait,
that.
oopsies.
Well,
Hold on.
No.